Okay, guys and gals, sorry I had to ditch. You've still got geometry you have to know, so I'm leaving you notes in the best form that I can come up with and still keep you moving ahead even though I can't be there. So make sure you write down everything. This is all you got. So we get into Chapter 5, and Chapter 5 is all about relationships within triangles. Chapter 4 was about relationships between two triangles. This one's about relationships within a triangle itself. There's a bunch of specialized vocabulary. You'll have to study it, memorize some terminologies. We'll start with the sort of the oddball of the whole group though. It's called a mid-segment. So a mid-segment sounds like middle, sounds like a segment, like a piece of a line. A mid-segment of a triangle is a segment whose endpoints are midpoints of two sides of the triangle. We'll start with that. So let's pick a side, maybe this sort of top looking side, kind of eyeball it and decide where you think the middle is. So maybe about right there. Okay, so that's a midpoint. Let's make a couple of tick marks to show that the two pieces of the side are equal. Therefore we know that point is in the middle. Alright, how about this bottom side? So kind of eyeball this bottom side. I'll turn it around so it looks like the bottom. And decide where you think the middle is. Put a point there. And we'll put a couple of tick marks on each side of that point to show that those two pieces are equal. And then connect the dots. Connect the points. Okay, that's a mid-segment. Now, there's two important things about a mid-segment you need to know before we even go up and finish the definition. First of all, that mid-segment, that line segment that we just drew, has a special relationship with the third side of the triangle. Actually, two relationships. That mid-segment is parallel to the side that it doesn't connect to. So that means this third side of the triangle is parallel to that mid-segment that we just drew. We're going to jot that down here under properties of a mid-segment. Each mid-segment of a triangle is, and let's write parallel to a side of the triangle. And then we need one more property. So let's go back and see if we can figure out what it is. So I'm going to use a pencil for this one because I'm probably going to go back and erase it. If I can find a pencil that works, probably not. Well, maybe we'll just do a light colored pencil. Oh, here we go. Found one. Let's say that this side of the triangle with the parallel mark on it is 10. So any guesses as to how long the mid-segment would be? If you guessed 5, you nailed it. Turns out that the mid-segment is half as long as the segment to which it's parallel. So if the side of the triangle is 10, the mid-segment parallel to it should be 5. So let's jot that one down. So the second property is each mid-segment of a triangle is half as long as the side to which it is parallel. Now it turns out that there are 3 mid-segments in every triangle. So I'm going to draw the other 2 ends just so you can see them. And I'm going to do them in different colors so it's a little easier to tell the difference. If I take this third side over here that I've not located the midpoint on and I locate where I think the middle is, let's say it's about right there. We'll do that in red. And 3 tick marks to show congruent pieces. If I draw in the connector of that midpoint to, say, the one between the sides with the 2 tick marks on them here, that mid-segment is parallel to the side of the triangle that it's not attached to. So that's sort of this top side up here. So those are parallel to each other. If you look closely, you can tell those go the same direction. It's reasonably well drawn. And I'm going to change colors one more time. And the third mid-segment connects the last 2 midpoints. So the top and the left midpoints, if you connect those, we'll do those in this kind of ugly brown color. That mid-segment I'm going to put 3 little arrowheads on it. That one's parallel to this bottom sort of right side. So 3 arrowheads on that to show parallel. So it's getting kind of crazy looking. So for each mid-segment, there's a side of the triangle that's parallel to it. And then there's one more thing that's kind of cool that pops out of this picture. Once you draw all 3 mid-segments in, you get 4 triangles, 4 smaller triangles, 1, 2, 3, 4, that are all the same size. They're congruent to each other. And they're half the size of the original triangle. So lots of special little relationships going on there. Alright, let's see what else we got to be able to do with these puppies. So now that we know what it looks like, what kinds of questions are we going to have to answer? Name the triangle sides that are parallel to the given side. Okay, so here's my picture. It's a little bit crazy to look at, but I'm going to name triangle side parallel to the given side. Okay, AB. Where is AB? AB's this. So I need a side of a triangle parallel to that. So I need one that goes the same direction. So I'm going to look for the mid-segment that goes the same direction. ZY, which is the side of this little middle triangle here, ZY is parallel to it. So I need a ZY here with the segment symbol. AC. Okay, AC is sort of the bottom of the big triangle. The mid-segment parallel to it is XY. It's the side of a smaller triangle. So side XY. CB. All right, CB is the right side of the triangle. That side is parallel to XZ of the smaller triangle in the middle. So that's an XZ. XY. Alright, that's a mid-segment. XY is a mid-segment. It's parallel to a side of the big triangle, which is AC. Technically, you could say AZ or ZC as well if you want to go with one of the smaller triangles. AC is the big triangle side, so we'll go with that one. So AC is the parallel side. Parallel to XY, that's... Did we not just do that one? That's a repeat. Let's just not even worry about that one. That's the same one we just did. Just mark it out. ZY. Okay, ZY is this mid-segment. Parallel to it's up here, AB. You could also use AX or XB. AB is the longer triangle side, so we'll go with that one. So, first thing you need to do is just to be able to find parallel parts and name them. Task number 2. Find missing measures. This should be a triangle symbol. Not sure what happened. It just didn't print off quite right. Points M, N, and P are midpoints of the sides of triangle QRS. So M, N, and P are midpoints. QR is 30. Okay, so from Q to R, that entire length is 30. R to S is 30. Okay, let's label that. SQ is 18. SQ is the bottom, it's 18. It is obviously not drawn to scale. Now let's break it down a little more. If I look at side QR, M is in the middle, which means from M to R is 15, from Q to M is 15. Those shorter pieces are each 15. Over on the right side, from R to N is 15, from N to S is 15. On the bottom of the triangle, we have a total of 18. P is in the middle. That means QP has to be 9 and PS has to be 9. Inside the triangle, we have some mid-segments. Each mid-segment is half as long as the side to which is parallel. So if the bottom side of the triangle is 18, then its parallel mid-segment MN is half of 18, which is 9. Notice that it's the same length as the 2 little triangle sides that it's parallel to. Alright, let's look at PM. MP is parallel to RS. RS is 30. Half of 30 is 15. So MP is 15. And PN is half as long as QR. So PN must also be 15. And once I write in all of the missing measures, it's really quick to fill in the gaps over here in the questions. Find the distance from M to N. Well, M to N is 9. It's labeled in the picture. That's all the work I really need to show. From Q to M, MQ. MQ is 15. Just look at your picture. MP. MP. That's this mid-segment. It's 15. P to S. P to S. That's 9. So all the work is really just getting your picture labeled. Once you get your picture labeled, you just look up measurements. You probably already expect what's coming next. Sometimes you got to do some algebra. So you might see situations where you're comparing one mid-segment to a side that is parallel to, like these 3 examples. They're a little simpler picture. That's a good part. The downside is you have to do some algebra. So here's your sort of formula. 2 times the mid-segment equals the parallel side. If you double the mid-segment, it's equal to the side that is parallel to. That's the easiest way to set these up. Now, technically, you don't really need any algebra, I don't think, on this first one. X is just half as long as 41. So you can just divide 41 by 2, and that's 20.5. So that one's pretty straightforward. But once you get to this second one, you've got a little more algebra involved. You got an x minus 8 involved. That's more work. So now we're going to use this idea up here of if we double the mid-segment. If we take x minus 8 and double it, 2 times x minus 8, that's going to be equal to the parallel side, which is 35. And then we'll do the algebra to figure out the rest. So distributive property says this is 2x minus 16 equals 35. If we add 16 to both sides, we get 2x equals 51. If we divide by 2, x equals 25.5. And we're done. Alright, same deal going on this third one. The shorter segment is 3x, the longer segment is 4x plus 20. Even though they're not drawn to scale, this definitely has to be shorter than this. If you double the short one, 2 times the mid-segment, the short one, 3x, equals the long one, 4x plus 20. 2 times 3x is 6x, equals 4x plus 20. Subtract 4x from each side, we get 2x equals 20. Divide by 2, we get x equals 10. Now on this one, if we substitute back in, 3 times 10 is 30. 4 times 10 is 40 plus 20 is 60. 30 and 60 makes sense because 60 is twice as long as 30. Alright, we're on the home stretch, just a little bit more here. D is the midpoint of AB. Right? AB and DB then would have to be equal. E is the midpoint of CB. That means BE is equal to CE. So DE is the mid-segment. Alright, let's see what we've got here. If measure of angle A is 70, measure of angle A is 70, find the measure of angle BDE. BDE. So that's this angle right here. Well, these are parallel. DE and AC are parallel sides, mid-segment rule. If those are parallel, that makes the angle we're looking for in 70 corresponding angles along parallel lines. Those are always equal. So that means BDE has to also be 70 degrees. So 70 degrees is our answer. Alright, keep going. If measure of angle BED is 73, BED, okay, that's this bottom right hand corner is 73. Alright, that angle is corresponding to angle ECA, or angle C down here in the bottom corner. That's also 73 because those are corresponding angles along parallel lines with BC as a transversal. So angle C then is 73 degrees. If DE is 23, okay, I'm going to change colors, it's getting hard to see. So DE is 23, so that's this piece. Then how long is AC? Find AC. Well, they're parallel. DE is the mid-segment. AC has to be twice as long. If you double 23, you get 46. So AC is 46. Alright, new problem. If AC is 83, okay, that's a new set of measurements, so I've got to change it. Now it's 83. New rule. Now it's 83. How long is DE? Well, DE is half as long. So if we do 83 divided by 2, that's 41.5. So DE is 41.5. Last one. I need to know the distance across the lake, and I can find some other distances more easily than measuring directly across the lake. If I set this up just right so that these distances are equal and these distances are equal, I can estimate the distance across this lake, because this question mark across the lake is a midsegment. A midsegment is half as long as the side to which it's parallel. That means this lake has to be half as long as 5.8 miles. So 5.8 divided by 2 is 2.9 miles. Alright, you have a worksheet of practice problems to do, and you and your neighbors can kind of help and talk things out if you get stuck. I will see you when I get back.